Data structure. It is a particular way of organizing and storing data in a computer so that it can be accessed and modified efficiently. A data structure will have a collection of data and functions or operations that can be applied on the data. Types of data structures. Primitive and non-primitive data structure. Primitive data structure defines a set of primitive elements that do not involve any other elements as its subparts. These are generally built-in data type in programming languages, integers, characters, etc. Non-primitive data structures are that defines a set of derived elements, such as arrays, structures, and classes. Linear and non-linear data structure. A data structure is said to be linear if its elements from a sequence and each element have a unique successor and predecessor. Stalk, queue. Non-linear data structures are used to represent data that have a hierarchical relationship among the elements. In non-linear data structure, every element has more than one predecessor and one successor. Static and dynamic data structure. A data structure is referred as static data structure if it is created before program during compilation time. The variables of static data structure have user-specified name. Array data structures that are created at runtime are called as dynamic data structure. The variables of this type are known always referred by user-defined name instead, using their addresses through pointers. Sequential and direct data structure. This classification is with respect to access operation associated with the data type. Sequential access means the locations are accessed in a sequential form. Operations on data structure. The basic operations that can be performed on a data structure are insertion operation of storing a new data element in a data structure. Deletion, the process of removal of data element from a data structure. Traversal. It involves processing of all data elements present in a data structure. Merging. It is a process of compiling the elements of two similar data structures to form a new data structure of the same type. Sorting. It involves arranging data element in a data structure in a specified order. Searching. It involves searching for the specified data element in a data structure. Complexity of algorithms. Generally, algorithms are measured in terms of time complexity and space complexity. Time complexity. Time complexity of an algorithm is a measure of how much time is required to execute an algorithm for a given number of inputs, and it is measured by its rate of growth relative to a standard function. Time complexity can be calculated by adding compilation time and execution time, or it can do by counting the number of steps in an algorithm. Space complexity. Space complexity of an algorithm is a measure of how much storage is required by the algorithm. Thus, space complexity is the amount of computer memory required during program execution as a function of input elements. The space requirement of algorithm can be performed at compilation time and runtime. Asymptotic analysis. For analysis of algorithm, it needs to calculate the complexity of algorithms in terms of resources, such as time and space. But when complexity is calculated, it does not provide the exact amount of resources required. Therefore, instead of taking exact amount of resources, the complexity of algorithm is represented in a general mathematical form, which will give the basic nature of algorithm. Thus, on analyzing an algorithm, it derives a mathematical formula to represent amount of time and space required for the execution. The asymptotic analysis of algorithm evaluates the performance of an algorithm in terms of input size. It calculates how does the time taken by an algorithm increases with input size. It focuses on analyzing the problem with large input size, considers only leading terms of formula, since the lower order term contracts lesser to the overall complexity as input grows larger, ignores the coefficient of leading term. Stack is a linear data structure in which all the insertion and deletion operations are done at one end, called top of the stack, and operations are performed in last-in first-out LIFO order. A stack can be implemented by using an array or by using linked list. The array representation method needs to set the amount memory needed initially. So they are limited in size, it can't shrink or expand. Linked list representation uses dynamic memory management method. So they are not limited in size, they can shrink, expand. Push operation. This function is used to store data into the stack. The push operation performs following steps. Check whether stack is full or not. If full, message that stack is full. If not full, it will increase the stack top by 1, and to that location, new data is stored. Applications of stack. Converting infix expression to postfix and prefix expression. Evaluating postfix expression. Checking nested parenthesis. Reversing a string. Processing. Dynamic memory allocation. The process of allocating memory at runtime is known as dynamic memory allocation. The special area in memory called heap is reserved for dynamic allocation. Any new dynamic variable created by a program consumes some memory in heap. The heap is a pool of memory from which new operator allocates memory. The memory allocated from system heap by using new operator can be deallocated by using delete operator. The users can dynamically allocate and deallocate memory for any built-in or user-defined data structure by using new and delete operators respectively. 1. New operator. The new operator creates a new dynamic object of a specified type and returns a pointer those points to this new object. If it fails to create the desired object, then it will return 0. My type asterisk PTR semicolon PTR equals new. My type 2-point delete operator period. The object created using new operator exits till it is explicitly deleted or till the program runs. To dynamically destroy an allocated object and free the space occupied by the object, the delete operator is used. Delete PTR. The delete operator eliminates the dynamic variable and returns the memory that it has occupied in the heap. The memory can then reuse to create new dynamic variables, trees. It is nonlinear data structure which contains a set of nodes and edges that have parent-child relationship. The starting node of a tree is called root node. Every other node other than root node have parent node. Each nodes of a tree can have any number of children. Tree terminology 1. Root. In a tree data structure, first node is known as root node. Any tree must have a root node, and there must be only one root node for a tree. Example. In the above tree node, A is called root node. 2. Edge. The connecting link between any two nodes is called as edge. In a tree with n of nodes, there will be maximum of n-1 edges. Edge AB connects node A and B3, parent node. The node which is predecessor of any node is called as parent node. B is parent of D and E and A is the parent of B and C. 4. Child node, which is successor of any node, is called child node. In a tree, any parent node can have any number of child nodes. The entire node except root node is child node. Here, B and C are children of A. Graph is a pictorial representation of set of objects where some pairs of objects are connected by links. The interconnected objects are represented by point called vertices, and the links that connect the vertices are called edges. Thus, the graph is pair of sets, V, E, where V is set of vertices the graph and E is set of edges. Vertex. Each node of a graph is termed as vertex. Edge represents the link between two vertices. Adjacency. Two vertices are adjacent if they are connected to each other through an edge. Path. Path represents a sequence of edges between two vertices. Searching. It is a technique that helps to find a place of a given element in a list. Any search option said to successful if element to be search is found. Otherwise, search option is unsuccessful. The standard techniques for search options are 1. Linear search. This is the simplest searching technique where search on a given array is done by traversing the array from beginning till the desired element is found. The time complexity of linear search is order of n, where n is number of elements in array. 2. Binary search. This search technique is done on a list of sorted elements.